Hello there. Today we're going to look at correlation. Now, correlation is a term that seems to be thrown around a lot and is often used incorrectly. Correlation is a measure of strength. It's only a measure of strength from two quantitative variables. Last time when we talked about a scatter plot, we looked at basically four things. We looked at direction, strength, form, and anything strange. So let's just do a little review. And first, let's compare the first two graphs. I want to compare these and talk about direction. Well, the first thing that I notice is that both graphs are kind of negative. Now, this one has a little bit of a curve in it, but they're both basically heading down. So then I would say that this first graph is really stronger than the second graph. Why? Well, because when we're talking about strength, we're talking about the points being really much closer together. And we can see in this graph, the points are all very close together. In this one, they're sort of scattered about. So for this one, we have a form that is basically a straight line. This one looks straighter than this one. This one's just a little curvy. And so when I talk about form, I want to talk about, is it straight like this graph, or is it curved, which is like that graph? And then I don't really see anything strange in either one of these graphs. And when I talk about strange, I mean, are there any big gaps or are there any outliers? But when I look at these two graphs, I can see a big gap here and I can see a big gap here. So these 2 points might be outliers. Now, outliers is a little bit different when we're talking about scatter plots. Outliers are not quite the same thing that they used to be. And here's kind of how I look at outliers now. It's called the pinky trick. So let's take a look at this one first. I see a dot that I think might be an outlier, but I'm not sure. So it looks like we have a positive direction here. But look at what happens when I put my pinky on the point. Once I put my pinky on the point, now we see that the direction has changed. So the rest of these points don't go with that point. See how if I move my pinky, the direction of the graph seems to change? Look at the graph over here. That doesn't happen when I do the pinky trick over here. When I put my pinky on this point, see, it is still the same direction. This point seems to be on trend with the rest of the dots, where this one, the trend seems to change when I move my finger back and forth across the dot. So if the trend changes, then that means that this point is probably highly influential and is probably an outlier. But over here, not so much. So really, when you're asked to identify anything that's strange, you're looking for something that actually changes the trend of the graph. Okay, so look at what happens when I add a line to this graph. If I add a line to this graph, I see that that point is way off. This is the point I'm looking at. But if I add a line to this point, if I add a line to that graph, then I see that this point is right on the line or very close to the line. It goes in the same direction as the rest of the points. So instead of, when we're looking for an outlier or something that's influential, it would actually, this point would actually suck the direction of the line off, and it would make it more like that, where this one just kind of stays the same. It really is the way that it seems. So that is a review of correlation. The next thing that I want to focus on is direction and strength. We're actually going to talk about something called the correlation coefficient. And the correlation is the R value. Now, don't let the little r fool you. It's actually a measure of strength. See, I put a little crown on it so that you would know that it's the king. It's the king of all the letters. And since it measures strength, it is something that is really, really powerful in statistics. So I want you to think about it like this. If you go to the gym and you see all the muscle heads and they're saying, yo, check it out, I just got a new tattoo. Look, I'm really, really, really strong. I'm 0.98. So that is a really, really, really strong R value. That's like an R value that wants to show off their strength. And they're very happy. So that this one's very happy. So it's positive. But you know, maybe there are unhappy people at the gym too. And so if this were a negative 0.98, then that would represent, wow, I'm still strong because I'm 0.98, but now I'm strong and I'm strong in a negative way. But we'll get back to that in just a few lessons. So let's talk about the value of R. So again, R is a measure of strength, but it can also be a measure of direction. So let's look at this next one. All right. So these R values, I have a couple of different examples for R's. I have a negative 1R, which means that these points are all perfectly lined up, but it's very, very strong because it goes all the way down to the smallest value that R can be. Since it's negative, it's slanted in a negative direction. Then here's another one, negative 0.7. Negative 0.7 is not as strong as negative 1, but it's still pretty strong. It means these points are all pretty close together and they're slanting down in a negative direction, but not all perfectly lined up like that one was. And then 0. 0 means that there's no association between one variable and the other. There's a whole lot of scatter going on in this graph. The positive 0.7 could be that the graph is still as strong as this one over here, it's just slanting in a different direction. And then positive 1 is the biggest R value that you can get. So again, it's okay, well, welcome back. Let's take a look at describing relationships. What do we do if we have two variables and we want to study the relationship between them? Well, what we're going to do is we're going to look for an association. We're going to see if there's one variable that is associated in some way with another variable. And that's the whole reason why we even study scatter plots. When we have two quantitative variables, scatter plots are really the only choice that we have for for establishing this relationship. We don't have any other graph that will allow us to graph two variables and graph them at the same time on the same axis to discover that relationship. So then I guess if we need to have two variables, we better name two variables. So the variables we're going to call x and y, not anything different than what we did when we were in algebra, and we're going to place the x on the horizontal axis and the y on the vertical axis. Now, when we work in context, we will refer to the x variable as the explanatory variable and the y variable as the response variable. So the words explanatory and response are important that you add to your vocabulary because these are going to be another term that we use for seeing what the relationship is between the two things that we're talking about for each individual problem. So be careful of a couple of things. There are a couple of really easy ways that you can lose points. One of them is to leave off a scale or to not number a scale consistently. It doesn't mean the x and the y scales have to be the same. They just, when you decide on a scale, it has to be done consistently. You also have to have labels and a title. Those are the AP graders are really, really serious about having titles and labels on the graph. Now, once we get our graph, we're going to be looking at four basic characteristics. We're going to be looking for the direction that the graph is going, either positive or negative. We're going to be looking for how strong it is, what form it takes, and if there's anything strange going on with the graph. So let's draw a graph and see what the direction, strength, form, and then any unusual features or anything strange that might be going on with that. And here we have our graph. Let's take a look at it. This is a graph where the two variables are attempting to show a relationship between the number of grams of carbs and the number of grams of fat in these McDonald's beef sandwiches. All right, so what do we see? Well, let's look at direction first. You can kind of do an easy test. If you can take your pen and lay it down and cover a lot of the points, whichever direction the pen is pointing is the direction of the graph. In this case, we know that the graph is positive because the pen is moving in a positive direction. If it were negative, we'd have the pen covering most of the points going like that. So this is a positively directed graph. Strength we're going to come back to in just a few minutes. But form, we don't see any particular curves or anything going through this, so the form is generally a straight line, and that's usually the forms we're looking for, either straight or curved, so that's pretty easy. And I don't see anything unusually strange about this. There may be a little bit of a gap in here, but not such a big gap that we would call it something strange. So, yeah, this is how we would be describing it. Positive, positively directed, straight or linear, and with no unusual features going on between these points. So the last thing, we want to try to determine if a strong association between two variables indicates a cause and effect relationship. You will almost always see this on the AP exam, and the answer is no. We talked about this in the very first lesson, where the only way you can establish a cause and effect relationship is with a well-designed, well-controlled experiment. So the answer here, no, no. Make sure that you put that into your notes too, because it will be on the test. Cause and effect can only be determined through experimentation. All right, well, I hope you guys are having a nice night, and I will see you tomorrow.